Alrighty, today we're going to learn about proportional relationships and slope. This is super important, everything you're going to do in math. There's the standard, this is the lesson. You're going to graph and compare proportional relationships using words, equations, and tables. Words, equations, and tables, and interpret the unit rate as the slope of the line. So we're talking about slope of the line. Here are the different ways that we do this. We have our unit rate when we have two quantities that are proportional and they have a constant ratio. Okay, that's our unit rate. So if I look at here, here's a words. The linear relationship is proportional when the ratio of x to y to x is constant. And here I will definitely see that I have a definite pattern. This is plus 1, plus 1, plus 1. Here I have plus 3, plus 3, plus 3. So that's a real constant rate. Because I'm going 3 up here, I'm going 1 up here. I could write it as a symbol, y over x, and then I could actually just graph it. So if I have an equation, y equals 3x, I have my intercept at 0, 0. I have points. I have a -1 and a -3. It's a point there. That's a point there. 1 and 3 there. It's a point there. I connect the dots. It makes a straight line. It's a linear function. This happens to be a linear relationship in this case here. This is an equation of a line. Here are the words. Here's the tables. There's the graph. Different ways of writing it. Okay, next page. One of the things I want you to highlight, obviously I showed you in the previous page that we have a linear equation. It's a straight line. So when we have something like y equals 3x, that's a linear equation. It's a straight line. The graph is a straight line. Now, when we have it set up, we have two variables. We have a y variable and we have an x variable. That's a variable. This is the input. Our x number is the input. The y value is the output. This is our constant. That's actually going to be our rate of change. If you'll notice here, the rate was 3 to 1, or 1 to 3, but in this case 3 to 1. You notice this is 3. So our rate is going to be our y over our x values. Okay, so it'd be 3 over 1 is our rate. It's also called our slope. So in this equation here, this is constant, that was our 3, it's also our rate of change. Remember, I write, you write is our rate of change. Independent variables, I think we went over that before, and these are outputs are dependent variables. Okay, this we could choose. This one has a choice. We choose this guy here. He's independent. This guy has absolutely no choice. He's 100% dependent upon whatever x is. So if I happen to choose, go back to our table, if I happen to choose the number 4 for our x, 4 for our x, well, I have to multiply it by 3 in order to get our y of 12. Okay, 2 times 3 is 6, 1 times 3 is 3, 0 times 3 is 0, -1 times 3 is a -3. So multiplied by 3, that is our rate. That's y equals 3x, multiplied by 3. So let's go ahead and take a look at learning more about rate of change. So since we're describing how they change, what the relationship it is, if it's constant, you'll see it's a constant rate of change. So take a look at this particular example right here. If I'm looking at this pattern here, we're going up 2 each time for our y. Time in minutes, we went up 1. So it's always the change in y over the change in x. 2 over 1. So our rate of change is 2 to 1, or we'll call it m equals 2. That is our slope. So when we have proportional relationships, we're dealing with slope. In this case here, if I had 8 minutes, we would say it's the same rate of change. I don't have to add 4, 5, 6, 7, 8. I just know that I'm going to multiply it by 2 and get 16. If I have 900 here, I'll now have 1800 multiplied by 2. So understand that that helps us quickly ascertain what our output would be. Now, knowing that this is now our slope. Slope is the rate of change between any 2 points on the line. This could be graphed. Oh, actually, it is graphed right here. Look at that. So the rate of change is our slope. So if I count all the way through, that's 2 units there, up 2, right 1, up 2, right 1. I could do this forever, right? The lines go on forever. I could do it forever. Up 2, right 1. So I'll go up 2 and right 1. That's my slope. Now, if for some reason I wanted to go backwards, I don't know why you'd want to do that, but that would go down 2 and left 1. Down 2 and left 1. Notice a negative 2 divided by negative 1 is still a positive 2. So the rate of change is constant on either direction of the line. Let's say, for example, I want to get really crazy. Let's get really crazy here. I'm going to go from here to here. I'm going to go up 1, 2, 3, 4, and right. Uh-oh. What's 4 divided by 2? It's still 2. So understand that the rate of change is going to be the same whether I pick 2 points right next to each other, 2 and 4, 3 and 6, 2, 4, 3, 6, or points away from each other. Because when I do the math on that, it's still going to be 2. Any point on the line, any 2 points on the line share the same slope. Let's say I did this here. This guy here, all the way down. Uh-oh, we're going to get really crazy now. To this guy here. So now I have 1, 2, 3. This is 1, 1. Sorry, start from 10. 1, 2. Excuse me 1 second. Oh my gosh. Hang on. Oh my goodness, was I recording? I don't know. Hopefully I was recording. Okay. Hang on a second. And if you noticed here, I went down 10 units and went to the left 5 units. If you go down or to the left, you always indicate that with a negative sign. You indicate your direction with a negative sign. A negative 10 divided by a negative 5 is a positive 2. So it still has, using this point here and this point here, it still has the slope of 2. So that's the whole point I want you to understand. So when I'm doing my change in my y, remember, I write, you write. I'm doing my change in my y over my change in my x. No matter what the values you have, no matter what you happen to use, understand a couple of things. When I'm moving along the line, if I'm going up, that value is going to be positive. If I'm going to the right, that value will be positive. If I'm going to the left, that value will be, whoop, I always do that. I always do it. If I'm going to the left, that value is negative. If I'm going down, that value will also be negative. So no matter how you slice and dice it, if I'm moving up and down is negative, up is positive, left is negative, right is positive. If you write that by the number, so for example, if I went down 10 units, okay, I went down 10 units, and I went to the left 5 units, that's a positive 2. By the same token, if I went up 10 units, I went the different direction, and to the right 2 units, and 5 units, that's still be a positive 2. So when I'm doing my slope, how can I get, while walking on the boxes, walking on the unit or the tick mark boxes, walking on these boxes here, same connected from here to here, going from this point here to this point here, I'll still get the same constant rate. I could go from this point here to this point here, and I'll still get the same constant rate for 2 over 1. Hopefully that makes sense to you. Makes sense in my head. All right. Let's see about Ava's savings. The graph shows the amount of money Ava saved over the first several weeks. Find and interpret the slope. What is the slope? You have to find it and interpret it. Then find the unit rate and compare it to the slope. All right. So let's go through this. Let's find and interpret the slope. Well, if I'm to do the counting, 1, 2. So I want to see. Now here it's not 1, 2, 3 necessarily. You'll notice my units here. I got 5 here. So this is 5 units here, 5 units. So I have 5, 10, 15. So I went up 15 here. And then I went right 1. So I think it's 15 to 1. I could be wrong. Let's try it again. Let's go from here to here. 1, 2, 3, 5, 10, 15. Yep. If I went from here to here, let's go from this point here to this point here. This is at 45. And I'll go 1, 2, 1, 2, 3 by 3. Guess what 45 divided by 3 is? 15. So I'm going to go with the slope is 15 to 1. So I'm looking at $15 per week. So my savings is the dollar is the vertical. Weeks, almost always time will be your horizontal axis. So my change in Y, my dollars over change in X, weeks, is $15 per week. That's how much she's saving, $15 per week. $15 per week. So if you just look at the questions they have here, find the slope, find the constant rate of change, which is what we did. And that's the rate, it's $15 per week. So the constant rate of change is $15 per week. Now in terms of what the slope is the mathematical technical point, the technical constant rate of change. So this is what the constant rate of change is. Constant rate of change is what does it mean in terms of context using real words. $15 per week. The slope is in the mathies, you know, the math speak. The slope of the line happens to be the same. So the constant rate of change is the same thing as the slope. Yay, next page. All right, this graph shows the relationship between feet and inches. So we have the number of inches and the number of feet. Well, that would make sense. If I have 1 foot, I have 12 inches. I have 2 feet, I have 24 inches, and so on. So here's my Y, here's my X. So let's just get this set up. My units are by 5s, but you see they went in between. Okay, that's fine, whatever. Here's the number of feet. Okay, so now I have, I'll use these 2 points over here. 24 minus 12, because this is my Y values up on top, X values on bottom. 24 minus 12, 2 minus 1, because I want to find out what that change is. So it's 12 or 1. Okay, so it's 12 to 1. If I were to go through it and count the numbers, it'd be 12. So my change in Y over my change in X, that's change, that's delta, it means change. It's 12 for every one. So no matter how I slice it and dice it, if I go from here to here, if I do 48 minus 12 and 4 minus 1, 36 divided by 3 is, again, 12 over 1, or just 12. So if I go through it, oh boy, I don't know what this means. I'm not even going to read it. This is the slope of the line, okay? And if I look at the unit rate and compare it to the slope, well, again, for every 12 feet, for every 12 inches, got my X's and Y's mixed up. My Y is feet, is inches. Oh my gosh, I'm just all over the place. For every 12 inches, I have 1 foot. There you go. I know I get it right eventually. If you write it out, it really helps. Inches and feet. So that is what we're looking at here. My slope is 12, which means, or 12 over 1. I'll take either one. Again, that's what I said, the fractions, I'm okay with your fractions, leaving it like that. Because we're dealing with 12, I'm counting units, 12 and 1. So that's what they mean. 12 inches to a foot are just 12, both the same. They're actually the same. So now we get to graph these proportional relationships. I don't have it. Geez, this is a long video. Okay, sorry, I hope I get done in time. So I need to graph these proportional relationships. So what I want you to do, I'm just going to get to example 2 right now. We're going to graph this. So the distance y in miles that a certain cyclist can ride and the time x in hours are proportional. This could be represented by y equals 12. This is directly proportional. Y equals 12x. Graph the equation. So whenever you graph an equation, you want to have at least, take it in terms of context. Oh boy.